Today we are going to have some mock revision on digital logic design. Okay, till now we have completed 3 weeks for digital electronics, and also we have designed different types of logic gates, Boolean algebra, K-maps, and different type of universal logic gates based circuits, and combinational logic circuits, sequential logic circuits, registers, counters, FSM, memories, right? So today we'll have a small recall on what are the topics we have discussed, and you can test yourself where you are lagging. We'll have some theory questions, understanding, and also some practical questions. Okay, so how the interview questions will be asked in general test, and also logical questions how the interviewers will be asking. We will have the discussion. Okay. So first of all, we will start with a very basic two problem statements. Okay. First, can you tell me what is the difference between nibble, bit, byte,
Nibble,
and word?
nibble means 4 bits together, ma'am. Byte means 8 bits together, ma'am. Word means 16 bits together, ma'am.
Okay. Double word,
Double one means 32 bits, ma'am.
32 bits. Okay, fine. Next, can you tell me what is the importance of digital logic design in VLSI? Why do we learn digital logic design first?
Yes, ma'am. Digital logic designs process information based on only binary numbers, either 0 or 1. It is very reliable and easy to store, and we use digital electronics because of now modern days. Every electronic components or hardware systems, from computer to satellites, we make it based on fundamentals blocks, and all these fundamental blocks are made only on digital electronics only. So digital electronics is the key way to implement any hardware components or any circuit designs, and it is very helpful and simplicity, and we, because of digital electronics, we reduce noise also. So this is very important, ma'am.
Okay. So whatever the applications we have in the industry or in the market, everything is a digital plus analog circuits. So internal, it is a combination of all digital blocks what we are learning in digital electronics, like combinational or sequential FSM, all lot of applications related FSM, and also memory. So that's why basic digital logic design is the basic subject we need to learn before entering into the design verification or into physical design. Okay. So first of all, we need to understand a clear cut of all the circuits whatever there in the digital logic design, not just theory. We need to understand practically how we can implement a circuit in many ways. Okay. So that is what exactly happened in the industry. That is what we work with in the industry. Suppose if you see, suppose you are designing a architecture which is a processor related computer architecture. It have different types of special purpose registers, general purpose registers. Suppose there are special purpose register like a program counter, accumulator is there. So it have its own functionality. Suppose instruction register which fetches the instruction, and like a data register is there which stores the data. Program counter is there which fetches the instruction from the memory. So if you want to design, if you are going to design those type of complex architecture, first of all you need to understand what is the purpose of normal register, how the shift register is working, how the linear feedback shift registers are working. Then only we can design the complex digital circuit architectures in future. Okay. So can you tell me what is the difference between combinational and sequential logic circuit?
Madam, firstly, combination circuit depends on the output depends on combination circuit. The output depends on the present input, whereas in sequential circuit, the output depends on the present input and the past output. In combination circuit, the combination circuit are not a memory element memory elements, whereas sequential is a memory element. It can store data, and there is no clock in combination circuits, whereas sequential circuits has clock, madam.
Okay.
Examples of combination circuits are adders, mux, encoders, decoders. An example for sequential circuits are latches, flip-flops, registers, counters, etc.
Okay, fine. Next, can you explain me what is the difference between latch and a flip-flop?
Yes, ma'am. Latch is a level sensitive element. Flip flop is a edge triggered element. Level sensitive means whenever enable is high, output will be changes continuously. Whereas in flip flop, output changes only in 0 to 1 transition or 1 to 0 transition, positive edge or negative edge trigger. Both latch and flip flop store 1 bit data.
What is the basic memory element of a latch? How the latch is designed?
By using NAND or NOR gates, ma'am. By cascading to NAND gates or NOR gates, ma'am.
Okay, fine. So, next, what are the major limitations of latches? Why do we prefer the flip-flop in real time?
There in JK flip flop on one condition it JK is toggled. In latches is level trigger. That's why the level edge input is changed to output change. Input change, output change. There is no controllability in latches. That's why we are moving to flip flops. Flip flops has a level edge trigger. The output is change only in edge in a positive edge or a negative edge to another edge only. That's why.
Flip-flop is not level trigger. Flip-flop is a edge trigger. First you told level trigger and you are telling the output will be changed with respect to the edge. Okay, complete it.
That's why you are using flip flops in the basic memory in sequential circuits.
Okay, so mainly why do we prefer flip-flop compared to latch? Means in latches the race around conditions will be occurred due to the uncontrollability of a output. Whenever the input changing, automatically the input change will be reflected to the output. So there will be lot of fluctuations in the output 0 1 0 1 0 1. So that's why to avoid the race condition mainly which is occurring in the JK flip-flop when both 1 1, when both inputs are 1 1, because the input is connected with respect to the feedback of output, right? Q is connected to the K, Q bar is connected to the J. Because of that uncontrollability, the race conditions will be occurred, keep on moving 0 1 0 1. So to avoid that, mainly we are preferring 3 methods. Can you tell me what are those 3 methods?
Yes, ma'am. The 3 methods are: first one is increasing propagation delay, and second one is clock edge, either positive edge or negative edge, and third one is JK master slave flip flop. First, propagation delay means we want to increase the propagation delay. By that, in latch, the output will be changed from logic 0 to logic 1 continuously. By increasing the propagation delay, it will increase the output, some controllability in the output. Second one is clock edge. By taking by positive edge or negative edge, the output will be stable. Another one is JK master slave. In JK master slave, we will connect the NOT gate to cascading by 2 JK flip flops latches. We will connect one NOT gate by giving clock 0 1 JK flip flop will work, and another one don't work on. By using that, we reduce the race around condition, eliminate.
Okay. So here 2 flip-flops are connected in a cascade. One flip-flop will be active, one flip-flop will be off. So that whenever one flip-flop is getting high, second flip-flop is automatically low. Like that we'll get the toggle condition where we can avoid the race around conditions. Okay, fine. Next, can you tell me what are the different types of flip-flops are there and applications of each flip-flop?
There are different types of flip-flops. One is JK flip-flop, SR flip-flop, T flip-flop, and D flip-flop. D flip-flop is used as storage flip-flop because it gives whatever the input we give, it stores and gives in the output. And T flip-flop, also known as toggle flip-flop, it toggles the whatever input we give. And SR flip-flop, it has a when we give 0 0 as the input, it gives the same output which is in the present state, and when it is 0 1 it gives the output 0, and 1 0 it gives 1, and when it is S and R is equals to 1, it gives invalid state. So to overcome this, we have the JK flip flop. In that, in J is equals to 1 and K is equals to 1, we have the toggling state that gives Q and bar.
Okay. Okay. Next, can you tell me how many bits are stored by flip-flop and a latch?
1 bit.
1 bit storage. Okay. So if we want to store multiple bits, what we need to do?
Register stores the n bit of
N-bit data. So that we need to cascade the uh, number of flip-flops together, so it will work as a register. Okay. What type of flip-flop is used to store the data as a register?
register. D flip flop.
The flip-flop. Why?
Because whatever we give the input, it will come output. D equal to Qn plus 1. So we use mostly D flip flop.
Okay.
Common storage.
Okay. So whatever the D input, output is also same.
Same.
0 means output 0, input 1 means output is also 1. So that's why mostly we prefer D flip-flop to work as a registers. Okay. Can you tell me what is the difference between register and a counter?
Registers will shift the input to the one state to another, and counters means it counts the clock pulses. And in registers we use D flip flop because whatever the input, the output will become. And in counters we use toggle condition to count the clock pulses.
Okay. Okay. Can you calculate the frequency of a single flip-flop? How the frequency division will be worked using a toggle flip-flop in counters mostly? Suppose a 4-bit counter is there. So what is the frequency at each counter?
For one flip flop T, we get the f by 2, and after that it will come T by 4, means half will be reduced, ma'am, by the cascading the T flip flop.
Okay. So why do we use T flip-flop for counter?
Because to count the clock pulse, we need only this toggle T flip flop.
Okay. Okay. Can you tell me what are the different types of counters out there?
Different type of counters, ma'am. We have asynchronous counters, ma'am. And different counters are up counter, down counter, up down counter, ring counter, Johnson counter, ma'am. Total
Okay.
5 counters.
What is the difference between asynchronous counters and synchronous?
In asynchronous counters, each flip flop have its own clock, ma'am. In synchronous counter, we will be having common clock, ma'am, for all the flip flops.
Okay. Then what is the difference between it? Which is mostly preferred, either asynchronous or synchronous?
We usually use synchronous, ma'am, because we will control all the flip flops using one clock, but it is somewhat slower, ma'am. But compared to in asynchronous, the clock pulses will be fast, ma'am.
Why? How?
Because for each individual flip flop, it will be having individual clock pulse, ma'am. That's why the output will come fast, ma'am. In synchronous, it is little
I
bit.
think asynchronous circuits will work slowly. Why? Because if you see, if we connect 4 flip-flops,
Yes, ma'am.
if there is a common clock, all 4 flip-flops will trigger at a time.
Yes, ma'am.
But in asynchronous, to get a signal for 4th flip-flop, it need to cross 3 flip-flops, then
depends
4th
on-
flip-flop should
It
get the
depends on
output.
previous
More delay,
output
ma'am.
clock.
Ah.
More delay.
So 4th flip-flop need to wait to complete until the
Yes,
first
ma'am.
3
Yes, ma'am.
flip-flops.
Yes, ma'am.
That's why it will take more delay in asynchronous circuits.
Circuits.
Whereas synchronous, every clock, every circuit will update with respect to the clock all at a time. So that synchronous have less delay.
In synchronous also, the output, the consecutive flip flops input depends on its previous outputs, no, ma'am.
Huh. That is
There will
flip-flop
be also
nature.
some delay, no, ma'am.
Flip-flop nature is output depends on input. That's what you are telling.
No, ma'am. In synchronous counters,
Mm.
For example, if we take 3-bit counter in synchronous, in the second flip flop input depends on its previous outputs, previous flip flops. So there will be some delay, no ma'am.
See, here you need to understand one point. Actually, how we are designing asynchronous counter.
Asynchronous,
Here counter 1, counter 2, counter 3. See, how we are designing asynchronous counter. Here it's a T flip flop.
Yes, ma'am.
I'm just giving overview idea. Here output is connected to next flip flop
Clocks.
clock. And also in asynchronous, we have different types, whether negative edge, positive edge, up down counter, up counter, down counter, like that. So if it is a up counter and positive edge, this one should be connected to the clock, or else Q bar should be connected to the clock. That will be dependent. Okay, but overall idea is here the clock is depending on output of first flip flop, and second clock is depending on output of second flip flop, and here this fourth clock is depending on output of third flip flop. That means this is what main clock. This is what main clock. With respect to this clock, here output is toggling like this. Now this output is clocked to second flip flop. So with respect to this positive edge of the clock, output is toggling like this. Now this clock will be the input to this, and here output. With respect to here, the output is toggling like this. We will take 0, 0, 1, 0, 1, 0. Like that is the process for asynchronous. But for synchronous, what we are doing, we just need to take the cycle first. All these this output, and here every output will be dependent on common clock only. Okay, same. This is what common clock in synchronous. With respect to this clock, outputs all will be dependent. Further, we have different process. What is that process? First of all, if you are doing up counter, 3-bit up counter, that means 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. After reaching 7, again it should go to 0. Now here you are drawing present state and next state table. Based on that, we are taking K-map. Based on that, we are taking the circuit diagram. That process is different wherever the clock is common to all. Okay. There, how you are drawing the circuit diagram? Did you observe clock circuit diagram? I mean waveform.
Synchronous.
For synchronous, you will get with respect to this clock only.
One clock only, ma'am.
One clock only. For remaining output, see there how you will draw means first flip flop, second flip flop, the third flip flop we will get the AND gate here. Okay. So from this you need to, with respect to the clock, what is the output? And here with respect to the clock, what is the output? With respect to the clock, what is the output? Then you will get the conditions here 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 based on up counter or down counter. Once try this, everyone. Just check the difference how asynchronous waveform is working, how synchronous waveform is working.
Here this flip flops input is dependent on this output number. So is there any delay? Is there any
delays? Internal clock delays will be there every time.
So it is also somewhat
here
slow.
There is a combinational logic circuit also. Internal delays will be there. But here input is not dependent on this. All inputs are by default one only, and here the input is dependent on this.
In synchronous, no ma'am. In asynchronous, by default we will get, ma'am. In synchronous,
the output will be connected to input.
Yes, ma'am.
Okay.
Then there will be delay, no ma'am.
See here, but here clock signal, it is same.
Yes, ma'am.
With respect to that, all will trigger at a time. But these are internal very few delays, less delay, limited, it will be not considered actually.
I thought we are using external gates, ma'am. I thought there will be extra delay for synchronous. So it will be
of course,
slower.
Extra delay will be there for external.
But in asynchronous, there will be no external gates.
Delay will be there.
In asynchronous, there will be no external gates, ma'am. I thought it will be somewhat fast.
No.
Okay.
Here to get an output to this flip flop, it need to cross these 3 flip flops. Obviously, there will be delay here, but these will work fastly.
Okay.
So these internal delays will be very less compared to clock delay. Okay. Next. What are the applications of finite state machine, and why do we need finite state machine?
Yes, ma'am. Finite state machine is nothing but it is a complex sequential circuit because of because we use sequential circuits to design digital electronics, but in sequential circuit also there is some more complex circuits. The circuits we are using FSMs. Likewise, for example, any ATM machine or vending machine, we have more complexity than the sequential circuits. To design these complex circuits, we use FSM machines. FSM machine is nothing but the output depends upon the next state, present state and the next state. What is the present state and what is the next state? And FSM has two types: More machine, More and Mere. More is the output depends upon only current state only. It has n number of states, and Mere is the output depend upon the current state and current input also. It has n minus 1 states. Because of n minus 1 states, its delay is less compared to More, but it has so many glitches and hazards because of synchronous clock. Because of there is two clock pulses we are applying. One is current state and current input also. So we prefer mostly More because to avoid these glitches and hazards we prefer More.
Okay. How can we avoid those glitches in Melee machine?
Yes, ma'am. In Melee machine, glitches are occurred. Glitch is nothing but sudden change in output. It doesn't affect the function block or output, but hazard is affects the output. To avoid these hazards, so there is three types of hazards: static hazards, static 0, static 1, and dynamic. Static hazards are nothing but 1 bit change. If when the output changes 1 bit only, then we use static. There is static hazard. When the output changes multiple bits, example 2 bits or 3 bits, that is dynamic hazard.
Basic switching algebra laws. గుర్తున్నాయిగా x plus 1 x plus 1 plus 1 1 x plus 0 x into x x into 1 x into 0 0 into 0 1 into 1 x plus x x into x x plus y y plus x x into y x plus x bar 1 Gopi x plus x bar ఎలా x plus x bar x 0 అయితే x bar ఏమైంది 1 0 plus 1 ఎంత 1 దానికి ఎందుకు కాన్సెప్ట్ ఆలోచిస్తున్నావు x into x bar ఎంత 0 into 1 0 x into x bar 0 x plus x bar 1 x bar plus x x double bar x double bar x x into x plus y x ఎలా చేస్తాం చేయండి x into x plus y x కామన్ తీస్తే 1 plus y 1 plus y 1 x మిగిలింది x plus of x into y x into y x okay x plus of x bar into y x into of x bar plus y x plus y x into y ఎలా చేస్తారు x plus of x bar into y
x bar into x plus y x
plus x bar into x plus y x plus x bar ఎంత గోపి 1 మిగిలేది x plus y ఓకే నెక్స్ట్ డిస్ట్రిబ్యూటివ్ లా x into y plus z x into of y plus z x y plus y z x plus of y z x plus z okay next డిమోర్గన్ లా డిమోర్గన్ లా చెప్పండి మీరే
A plus B equal to A bar into B bar whole bar.
a plus b
A plus B equal to A bar into B bar whole bar.
కాదు.
A plus B whole bar equal to A bar into B bar.
A plus B whole bar is equal to A bar into B bar. A bar A into B whole bar is equal to A bar plus B bar.
గోపి.
A plus B whole bar is equal to A bar plus B bar. A into B whole bar is equal to A bar into Y B bar.
కరెక్టేనా? మీరు x ఇంటూ వై, అసలు x ఇంటూ వై ఎందుకు వస్తుంది? a ప్లస్ బి హోల్ x ఆర్ y వాట్ ఎవర్ ఇట్ ఈస్, a ప్లస్ బి హోల్ బార్ ఇస్ ఈక్వల్ టు a బార్ ఇంటూ b బార్. a ప్లస్ బి హోల్ బార్ అయితే a ఇంటూ బి హోల్ బార్ అంటే a బార్ ప్లస్ b బార్. మీరు అదా చెప్పింది?
నేను చెప్పిన కరెక్టే మ్యామ్, కానీ ఇట్లా చెప్పకూడదు.
ఓకే, నెక్స్ట్ మీరు డ్రా చేశారా 4x1 మల్టీప్లెక్సర్ యూజింగ్ 16 by? ఓకే, what are the applications of multiplexer and what are the different names of multiplexer?
మల్టీప్లెక్సర్ అప్లికేషన్స్ వచ్చేసి parallel to serial conversion ma'am, and many to one, and it is also used as universal gate ma'am.
How? Why do we call
we
it?
can, we can design basic gates ma'am, like AND gate, NOR gate, XOR gate by using multiplexers ma'am.
నెక్స్ట్ క్వశ్చన్ రాసుకోండి. మీరు కాదు. ఎండ్ గేట్ డిలే 8 నానోసెకండ్స్, ఆర్ గేట్ డిలే 12 నానోసెకండ్స్, నాట్ గేట్ డిలే 4 నానోసెకండ్స్. Okay, if the circuit has two end gates feeding into an OR gate,
Two AND gates.
feeding into an OR gate, and one NOT gate in the input path of the second AND gate. One NOT gate in the input path of the second AND gate. Calculate the total worst case propagation delay. Next question. Design a circuit for vending machine that dispenses a product when it receives 5 rupees. The machine accepts 1 rupee coin and 2 rupee coins. Write the state diagram and implement using D flip-flops. And explain the output, how it is tested. Is it coming expected or not? Next, design a 4-bit counter that skip 1001. 4-bit counter that skip 1001. Identify at least 2 possible reasons why and suggest the debugging steps.
Why? And suggest.
What are the debugging cases? అది వదిలేయండి, జస్ట్ డిజైన్ చేయండి సర్క్యూట్.
Okay.
ఒకసారి వెండింగ్ మిషన్ క్వశ్చన్ చెప్పండి.
Design a vending machine that dispenses a product when it receives 5 rupees. The machine accepts 1 rupee and 2 rupee coins, and draw the state diagram. Next, Gopi. Design an inverter using XOR and XNOR, and design a buffer using XOR and XNOR. And next, Meeru. Design a half adder. Design a full adder using 2 half adders and then OR, and write the sum and carry expressions. And next, Meeru. Implement a decimal to BCD circuit for decimal digit 0 to 9.
Implement.
Implement a decimal to BCD circuit 0 to 9, decimal digit 0 to 9 using 4-bit binary input and detect invalid inputs greater than 9. అర్థమైందా? బీసీడీ టు డెసిమల్ సర్క్యూట్ని డిజైన్ చేయాలి, 0 to 9 ప్రింట్ చేయాలి. 0 to 9 కంటే ఎక్కువ ప్రింట్ అవుతాయి, ఆఫ్టర్ 9 ప్రింట్ అవుతే ఇట్ షుడ్ డిటెక్ట్ దీస్ ఆర్ ద ఇన్వాలిడ్ ఇన్పుట్స్ అని డిటెక్ట్ చేయాలి. దానికి మీరు సర్క్యూట్ డయాగ్రామ్ డ్రా చేయాలి. ఆ క్వశ్చన్ గుర్తుపెట్టుకొని వెరీలాగ్ స్టార్ట్ అయినాక వెరీలాగ్ ప్రోగ్రామ్ కూడా డిజైన్ చేయాలి. ఓకే, నెక్స్ట్ implement f is equal to a into b plus c using NAND gates, only NAND gates. Next, design priority encoder for 8 inputs. Give Boolean for highest priority input. Next, create 3 to 8 decoder using 2 to 4 decoders. And OR gate or enable lines. Next, design a combinational logic circuit that outputs 1 if a 4-bit input has even parity.
4-bit input.
If 4-bit input has even parity, then write what is the expression. Next, design modulo 6 synchronous counter using JK flip-flops. Next, mirror Spitzer. Implement a Johnson counter. Implement a Johnson counter of 4 bits. Next, implement divide by 8 counter. Divide by 8 counter using T flip-flop. Next, design edge detector to produce 1 clock pulse. Design edge detector to produce 1 clock pulse on rising edge of asynchronous input. On rising edge of asynchronous input. Next, a 4-bit ring counter randomly deadlocks to all zeros when power applied. Why it is and fix it. Next, design a Mealy FSM that outputs 1 if input sequence 101 occurs overlapping allowed. When 101 occurs, overlapping allowed. Provide the state diagram. Next, Design a synchronous up or down counter. Design a synchronous up or down 3-bit counter using T flip-flops. Next, design a 4x1 multiplexer using NAND gates. What is one hot encoding in FSM? One hot encoding in FSM. Memories concepts అయిపోయినాయా?
క్లాసిఫికేషన్ మాత్రం అయింది.
నెక్స్ట్ క్వశ్చన్ రాసుకోండి. మెమొరీ రిలేటెడ్ ప్రాబ్లమ్స్ ఒక్కొక్కరికి ఒక్కొక్కటి ఇస్తున్నాను. ఇప్పుడు దాకా ఎవరికైతే ఏ ప్రాబ్లమ్స్ చెప్పానో అన్నీ ఒక షార్ట్ నోట్ చేసుకొని ఆఫ్టర్నూన్ అందరు కూర్చొని అవి కంప్లీట్ చేయండి. అన్ని క్వశ్చన్స్ అందరు కూర్చొని కంప్లీట్ చేయండి. మెమొరీ రిలేటెడ్ ఇస్తున్నాను, చేయండి. మీకు మెమొరీ రిలేటెడ్ చేయలేదు కదా, ఏమి ఎక్కడైనా సెర్చ్ చేసి గూగుల్లో అట్లా ట్రై టు అండర్స్టాండ్ రాసుకోండి. Address decoding related. You have a 64 KB memory chip. అందరు రాస్తున్నారా? రాయండి. You have a 64 KB memory chip with a 8-bit data width. With 8-bit data width. How many address lines are required? If you connect 4 such chips in parallel, to create a 32-bit wide memory, how many total address lines and control lines are required? Total address lines and control lines are required. ఈ చేసే ముందు నేను ఒకసారి మీకు ఫీఫో కాన్సెప్ట్ ర్యామ్ రోమ్ గురించి చెప్తాను, ఆ తర్వాత చేద్దరు కానీ. హౌ మెనీ టోటల్ అడ్రస్ లైన్స్ అండ్ కంట్రోల్ లైన్స్ ఆర్ రిక్వైర్డ్? నెక్స్ట్, డిజైన్ ఏ 16/4 ROM. Design a 16/4 ROM using a decoder and OR gates. How many input lines are required for the decoder? Draw the truth table for the ROM. ముందు రెండు చేయించాలి.